So let's go live. What is up, everybody? And I'm so excited. I forgot to put my sunglasses on. It is Data on Kubernetes live stream number 134. Yes, we're getting closer and closer to 135. That's exciting, which will actually be tomorrow. But today we got live stream 134. Extra excited about this one because we are here to make history. It is not every day in the Data on Kubernetes community that we are talking to folks with the ambition, with the goal, with the drive to get an open source project into the CNCF as a sandbox project. I love the ambition. I love the energy and passion behind this. We got a little sneak peek, a little preview at KubeCon about this particular project from the two wonderful folks that we have with us today. They are named Leonardo, and I'm not going to destroy your surname. I will be kind and generous in that sense. And Gabriele, very nice to have both of you with us. Two wonderful humans from EDB, absolutely rocking on all things open source Postgres on Kubernetes. Gabriele, we already do know you. We haven't had a chance yet, though, to have Leonardo with us on a live stream. Leonardo, anything that you would like to add as an introduction?
Hi. A few words. I'm a programmer. I love programming. I love data, and this is great. By the way, and data on Kubernetes is even great. So yeah, perfect.
Excellent, excellent, excellent. Good. And Leonardo, where are you joining us from? I believe you are in Italy, correct?
Yeah, exactly. Italy, Prato.
Okay, okay. So, oh man, oh wow. This is the power of Prato. How do you say as someone from Prato? How do you say a person who's from Prato? How do you say that?
Pratese.
Okay. Oh yeah, of course. Like Calabrese. That's right. Okay, cool. So, but different parts of the country, I know we have to be careful north and south.
But we are right? Tuscany, from Tuscany.
It's a beautiful area. Folks, if you have not been to Tuscany, it's not hype. This place is gorgeous. It is amazing. And I was asking Gabriele about when they're going to do a meetup so that I can have an excuse to go there. Anyway, great place. Also known for blues music, blues festival. It's close by, so you can check it out.
Yeah, close by. Yeah,
close by. Anyway, that being said, if you got questions, as usual, folks, drop them in the YouTube chat. We'll be happy to answer them accordingly. Also, just massive shout out to both these gentlemen for being amazing Data on Kubernetes community members. If you have questions, if you're curious about something, if you want more information, reach out and talk to them on Slack and they'll be happy to answer. You'll get a timely response. So keep that in mind. That being said, I will let you take it away and I will enjoy from behind the scenes. Go for it.
Thanks, Bart. And yeah, hi everyone. So let me share my screen.
Yep, looking good.
Can we see the full screen? Okay, yes, good.
Perfect.
So, so that's, myself and Leonardo, we both, we both work for EDB. Just a quick reminder that I've been using Postgres for many years, more than 20 probably, and I'm now vice president of Cloud Native at EDB, and I was lucky enough to be one of the people that open source CloudNativePG. And I've been here, a few times, and it's always nice to be part of this community. But I'm very happy that tonight Leonardo is with us, because Leonardo is actually one of the, people that have created this amazing piece of software. So I leave it to you, Leo, if you want to add something else from what you said before.
Yeah. I'm one of the first, developers of CloudNativePG, and this is a great honor for me, and it's awesome. And yeah, I think it's a really interesting technology, and that at least our point of view of how Postgres should be deployed in Kubernetes is really interesting. And yeah, just a few words, but I think the best way to appreciate that is just testing the software we are releasing
and trying. Yeah.
Yeah.
Okay. Yeah. Thanks. So basically, I'll go over, with some slides first, and then Leo will provide a demo of the software. So what we're talking about here is, Kubernetes, and if you've got the insane idea to run Postgres in Kubernetes, not on Kubernetes. I mean, I think it's different, it's, there's a one letter difference, but in my opinion, that's what makes the difference. And so Postgres, and then manage Postgres in Kubernetes with CloudNativePG, which is our operator that we will be talking about tonight. Okay. So, and the interesting thing is to create an ecosystem where these three technologies can work well together. So that's the ambition that we have, is that we want to bring Postgres in Kubernetes, and we also want to bring Kubernetes in Postgres, because we want to be active members in both communities. Of course, we know better the Postgres one, but we are trying to understand better, also thanks to the data on Kubernetes community, the Kubernetes one. So we want to, generate the opportunity to improve how these two technologies work together, and these two communities can learn from each other. So I want to thank first, EDB, which is a company, but it's also the company that has been using this software for already in production for over a year and a half. And I'm really happy that the management agreed on releasing open source this software, and not only releasing open source, but also donating the IP to the community. So basically what's happening is that the idea is that the CNCF will end up owning this software. Okay, so EDB, just so that you know, is probably the largest contributor to the Postgres project. Okay, the Postgres open source project. We also have, a fork of Postgres and some proprietary tools, but we should never forget that, we also heavily contribute to the open source software, to the open source Postgres. And when it comes to Kubernetes, we are certified service providers. So we are a KCSP, and we are also platinum sponsors of the data on Kubernetes community that, we believe that it's strategic for the cultural change that we are facing, because I mean, the opinion is still that, and even, yesterday on LinkedIn, Bart, asked me to intervene. We still see, this common opinion that data shouldn't run in Kubernetes, and especially databases, for example. So if you want to know my point of view, there's this blog article that went through the CNCF channels that is a month old, and I explained the reasons why it is important, and I mean the benefits of running Postgres inside Kubernetes alongside applications. Anyway, we're talking about CloudNativePG project. First of all, we have to think about the CloudNativePG organization, which is basically the set of people that have contributed so far to this project. Okay, there's no single organization, single vendors that own the software, but it's this community that is built upon some principles and values and some governance policies that I'll show you later on in this presentation. But the organization at the moment is responsible for three major projects. One is of course, the operator. That's the main project, and here is the URL, the CloudNativePG operator. Then another important project is the one that builds regularly on a daily cadence the operand images for Postgres, and the Helm chart project. The software is released under Apache 2 license with IP owned by the CloudNativePG contributors. So what I was saying before is that we and Bart was actually saying that initially is that we have applied for the CNCF Sandbox at the end of April. So okay, our commitment is to try and get all the way down as a graduated project. Of course, there's only it's not entirely dependent on us. But at least we've got the commitment, and we want to make it happen. Okay, so we will follow what the CNCF suggests us to do, and we are welcoming, of course, multiple vendors to join EDB in this effort. It is the first Postgres in Kubernetes project that is attempting this. When we talk about Postgres, I want to remember that we're talking about an open source project that is, very robust. It's probably one of the most successful open source projects in human history. And one amazing thing is that it's been consistent in its growth for over the last 20 years. Okay, if you look at how it was 20 years ago and how it is now, you can see, the increase of the enhancements in features and capabilities that have been introduced over time. Here is my favorite list of features. Of course, one is standard SQL, which I have highlighted. I'll show you in the next slide why. Transactional DDL, sorry, then continuous backup, point-in-time recovery. These are all enterprise level features that make Postgres a database suitable for business critical and mission critical scenarios. Native streaming replication, which is very robust, and it also supports synchronous, and that's one of the reasons why our operator is using the application level. So when I talk about application, I mean Postgres replication for disaster recovery instead of storage level replication. That's because PostgreSQL replication is very advanced, very robust. Okay, it's been in production for 15 years. Okay, so we're talking about a very mature technology that can even be controlled at transaction level. Okay, so for example, if one transaction, I'm talking about an ICID transaction, it's important, I can request Postgres to make it synchronous. So make sure that it's written, for example, on two instances. So for example, in Kubernetes, in one availability zone and in another, before the control is returned to the user.
Can I ask a question really quickly?
Yep.
This is actually a question from me, which is not common. Normally it's from the audience. Is that it came up 2 weeks ago after KubeCon. I was at another event, and I am not interested in pointing fingers, and I don't want to start a fight or a war over this. But someone was talking about how if you're using Postgres, that getting additional technologies for backup and restore simply aren't necessary because of PG dump. I don't want to cause controversy, but what's your take on that? Okay,
it's funny because in a few weeks it will be 10 years since we have released Barman open source. Barman is backup and recovery manager for Postgres, and it's a software that which I'm one of the creators, is one of the top 3 backup solutions for Postgres. And the reason why we created Barman is because at the time there was no, PG dump and PG restore, because they take snapshots.
Got it.
They don't cover you from, they don't enable you to perform point-in-time recovery. So if you take a backup once a day at 9 a.m. and you've got a failure at 8:30 a.m. the following day, you have lost 23 hours and 30 minutes of data.
That's not good.
Whereas with continuous backup, you can take advantage of point-in-time recovery and rebuild the cluster up to, for example, the second before the incident. And that's a feature that made Postgres very applicable for large businesses, and that's what made the fortune of the fortune of Postgres in the probably mid 2000, when pretty much all startups started to use Postgres.
Got it. Okay.
Because it was very robust. Okay, so because I would say that we are experts in these areas.
I would too if you created Barman. I would consider you an expert.
But also, we should never forget our colleagues that have actually written these technologies inside Postgres itself. Okay, because we are just I'd say imposters of we're talking about these features, but I've contributed only to a few patches in Postgres, but I've pretty much worked around Postgres. But we should never forget all the core developers of Postgres that are doing an amazing job. Okay, and I feel lucky that many of them are within EDB in our company. Okay, so anyway, this is just a few. These are just a few features. Declarative partitioning. Also, JSON support is really another important feature for developers, because with SQL now we can query and manage data that is both structured and unstructured using SQL in an SQL database. PostgreSQL, it supports this primary standby architecture, so it means that there's only one active database that is writing at any time, and we've got 0 or more replicas that are useful for high availability, but they can also be used for read-only queries. So this is what I was referring before when I highlighted standard SQL. I think one also of the goals of this project is that, and I was talking to Bart about this, in Valencia. We feel that SQL is probably one of the most underrated languages that we have. Okay, we think that it's an old language, that it's useless, but it's actually very, very powerful and robust, and it's standard. Okay, it's an amazing language, in my opinion, for manipulating any sort of data. And it's optimized for concurrent access and also controlled access if you don't want, for example, some people to read some data, and it's all there. Okay, and maybe, just by looking at it in a superficial way, we actually underestimate the power of SQL and how it can actually simplify the work that you do as a programmer, because instead of doing the calculations on your side, you can actually ask with a single query the database to perform those calculations in an actually more efficient way, because data is used directly in the database server, so it doesn't have to get to your server first and then you calculate that and then you return the value. And PostgreSQL is a very nice technology to learn SQL. So, in my opinion, with this software, with CloudNativePG, because the complexity of deploying a Postgres instance cluster is hidden from you now, you can actually focus on learning SQL directly in Kubernetes. So if you are new to IT, you are a student, or you just started your development career, I think this could be an interesting way to grow on a professional level and to become more efficient at developing applications. So I think we've got some ideas with Bart as well here, so stay tuned, in the next weeks or months on this topic.
Most definitely.
So briefly, when we talk about CloudNativePG, we're not talking about a project that started, 2 months ago. I was at the time, I was head of support at Second Quadrant which was acquired, as you can see, in September 2020 by ADB. And I was asked to lead the Cloud Native initiative at that time. And we wrote in September, that's when we began writing our own operator from scratch, after we actually evaluated the existing technologies. We tried to use a Kubernetes administrator approach because, for example, Leonardo was one of the people involved. He was a CKA, Kubernetes administrator, and also he had studied how to build operators. And we came to the decision of pretty much starting a new project that wasn't using an external tool like, for example, Bartolini for failover management. And we wanted to actually use the Kubernetes API server for that purpose and program how failover was handled. So failover is when, for example, the primary goes down and we need to automatically intervene, react, and for example, promote the most advanced replica as the new primary, okay? Excuse me. Yeah. So this is the approach that Leonardo was referring to before when he said that we took a different approach. That's a different approach. Then we became KCSP, and we launched in 1.5 years ago CloudNative PostgreSQL. That's how the software was called at EDB. And in February, we decided to open source it, but we launched it in April and submitted to the CNCF Sandbox. And in May, I was very happy to present the project to the technical advisory group of storage in the CNCF. I was asked, at KubeCon, why are you contributing Cloud Native to CNCF? I mean, when I was studying leadership, I studied this concept called wicked problems. Okay, wicked problems, they are problems that are maybe they're too complex that require, a different, maybe multiple angle. I mean, some actions from multiple angles and careful exploratory kind of mindset, okay, to address them. So the problem was that, in our opinion, the database adoption is still lagging in Kubernetes and vice versa. So even the Kubernetes adoption in the PostgreSQL or database sector. And we believe that, a single vendor, cannot solve this problem, and that a holistic approach is required. For example, even the involvement in the data on Kubernetes community is very important because it's a cultural change that we need to trigger, and that requires time. That requires, a lot of meetups like these. It requires people talking. It requires everyone going through this change journey by themselves to understand why this is important and where the benefit for them is. Okay, if there's no benefit, we shouldn't just change technologies. We need to be focused on the goals. These are always means. Okay, it could be that one day Kubernetes is not the answer anymore because there's the new Kubernetes technology, and it's this kind of mindset that we need to have so that we are always ready to change. Okay, so we believe that it is important to try several things, and so for us, the thing that made more sense was to lay the foundation. I wouldn't say start, because we cannot force people to join, but I think what we've done is to lay the foundation of a vendor neutral and openly governed community. If you look at all the documents that we have published, and they're all based and inspired by the CNCF policies and principles, as I said before. I think you can see that it's truly, that's our intention. Okay. So the idea is that this way, multiple companies, multiple users can join us and promote Postgres in the Kubernetes ecosystem. At the same time, when there's more people that will be using Postgres in Kubernetes, We can also provide feedback to the Postgres community and improve Postgres so that the container context is a first-class citizen, okay, not a second-class citizen like, probably, we are used to now with VMs or bare metal installations that are still dominant in the database world, okay. So this is pretty much the reason. So I would like to share, this is the homepage of the project, so that everyone can start, becoming familiar with CloudNativePG. So this is cloudnativepg.io is the website, and from there you can find a link to the documentation, to the blog. You can find the link to the GitHub project as well, which is this one. So it's cloudnativepg/cloudnativepg. The project, when we open sourced it, it was made up of more than 1,400 commits. Okay, so you can actually see the whole history of CloudNativePG since the start. So as I said, this is not a project that was born, a month ago or so. This is another important project. The operator needs the operands, okay, to run. Okay, so the operator controls the operand images. For us, the operand images are the Postgres images, the images that contain Postgres. The approach that we took is to enable everyone to customize the images, adding, for example, extensions that they want. Postgres has several extensions, is an extensible database engine, so you can add your extensions to the layers of the images. This is an example of an operand image, the way we build it. Okay, we use the Docker Hub official images for Postgres as a base image, and then on top of that we add some layers. In particular, we add PG Audit, the PG Audit library, and Barman Cloud, which is used for backup and recovery to object stores. Okay, the last one is that we use the UID 26 to run Postgres, because we are using an application container paradigm where Postgres doesn't run as root, okay, or the container doesn't run as root. We run it as a Postgres user. There's also a section for the frequently asked questions. So if you want, you can go there and get some answers. And then this is the documentation of CloudNativePG. For example, one way to contribute is, if you want to help and improve the documentation, because it's built like a scar tissue. So basically, we started to, once we added features, we started to add sections, but I think at this point it's quite large that it requires probably stepping back and rewriting it. So I think to understand what Cloud Native Postgres is, the best way is with an example. We follow convention over configuration, and we follow declarative configuration. So with just a YAML manifest, you are able to create a cluster. So in this case, for example, we specify Postgres 14.3 as the version that we want to install, which is the latest one. We create a cluster with this API, okay? The cluster is the resource, the CRD that the operator, one of the CRDs that the operator manages, and that's the main one. We create a cluster called MyAppDB with 3 instances, meaning there's 1 primary and 2 replicas. And each of these instances has a volume using the default storage class of 10 gigabytes. So this is what happens, okay, under the hood. PostgreSQL the operator creates one pod for the blue one, okay, for DB for the first instance of the database, one pod for the second, and one pod for the third, each one with a local persistent volume, and the persistent volume claim. Then it generates also additional resources like secrets, config maps, roles, role bindings, service accounts, and so on. And also two services. There's actually a third one, but I'll focus on the primary, which is the RW and the read-only service. So every time to the applications, if they point to the RW service, they're always redirected to the primary. That's what the operator does. And these are the standbys that are using streaming replication to be continuously synchronized. And then we've got the PVCs where the PG data, the Postgres data directory is stored. I don't know, Leo, if you want to cover some of these topics, that's fine with me, because I always talk about these, but but given that you are,
I can just shed a few words about it, but yeah, if you want to contribute. Okay, the main point of the operator when it comes to managing a cluster is to ensure that the primary, which is the instance on which you can execute read and read-write queries, is always available. So the operator will take care of it and will choose the right action to take. To do that, it needs a way to check if everything is running correctly or not. And we are just using Kubernetes for that. So this is the role of the probes. We have liveness probes, we have readiness probes, and readiness probes are the ones that are used to check if the primary is correct or not, it's fine or not. When the primary is not working anymore, we fail over, we select a new replica and we promote it to become the new primary. And when the user change the specification of the cluster, we are going to create a new replica or just to delete one. So they scale up, scale down. When we promote another replica and their primary after that is recovered, the primary will be reattached to the cluster and will be basically resynchronized. This is under the hood using a program which is called pgrewind inside Postgres. Besides being able to handle automatic failovers, we can also execute planned switchovers. And everything I was talking about is being used to apply rolling update and to be able to scale up and scale down an existing cluster.
Yeah, thanks, Leo. So this is, for example, what's happening when there's a failover. This is the failover. So there's a problem on the pod, and so the readiness probe fails, and the operator detects that. And what's happening here is that it promotes the second instance, redirects automatically the service, and then when the first instance comes back, it makes it follow the new primary, and then adds it to the read-only service. So in terms of storage management, we've been working with databases for so long, and we know that storage is the most critical component. Okay. And we follow that approach also when we design the operator. And for us, the central piece for a cluster it's the actual PG data. So for us, the PVC that stores the PG data is the most important component that actually dictates the whole orchestration of a Postgres cluster. Okay, that's what it's all built around that concept. The good thing is that CloudNativePG is pretty much agnostic to storage, so you can use any storage you want, local storage or network storage based on your needs, and you need to accept the consequences in each direction. So if you've got network storage, you need to accept that there's variability of performance. If you choose local storage, you've got more predictability, probably more performance, but maybe more maintenance burden. Okay, but I think it's your choice. That's a good thing. We support persistent volume claims, and we support PVC templates and also storage classes if you want to define the storage. But there's much more. As we said before, there's rolling updates. There's pod security policy support, TLS connections, authentication out of the box, with also integration with Cert Manager if you need to. Continuous backup and point-in-time recovery to the point that you can configure your cluster to back up to an object store and have less than 5 minutes of RPO, recovery point objective, out of the box. We comply with Kubernetes resource management and pod scheduling policies. We have a native Prometheus exporter. We directly export in JSON log in standard output. We have an extensive number of end-to-end tests that you can actually inspect in GitHub. We have multiple bootstrapping methods, and you'll see one shortly. So it means that, for example, you can create a new cluster starting from an existing one, or from a backup, from a continuous backup. It supports synchronous replication and the replica cluster, which is the feature that I'm describing now. So suppose you've got one cluster in a Kubernetes cluster in Europe, and this cluster has a primary and two standbys, and it archives to a local object store in let's say in a public cloud. Then you've got another Kubernetes cluster in the US. We call the primary, which is not a primary, a designated primary. We use a symmetric architecture, so it's pretty much the same. This is a different cluster that is using cascading replication, which is available in Postgres, to collect data from the object store. So basically, you can use the yellow arrow here to create and also feed continuously the designated primary, which then uses stream replication to update the standbys. So with just this setup, so without any active connection between the two data centers, you already have a disaster recovery solution that is aligned in the worst case scenario to 5 minutes ago. Okay, this comes out of the box, and if you want to, you can add, a channel between the two clusters and introduce streaming replication within the two clusters to reduce the RPO in a cross-region disaster recovery situation. So this feature is available. I want to, before we go with the demo of Leonardo, we are planning to release 1.16 on June 23, and the major feature is the import of an existing database, Postgres database inside a CloudNativePG managed database. So this is also this is a use case. So if you've got an old Postgres version in a VM or in a bare metal or in another Kubernetes cluster, you can import that into CloudNativePG just by using a network connection. And also, if you want to upgrade a version of Postgres, so for example, from 10 to 14, you can use this technology. Okay. We have introduced two types of imports. Yeah, sorry, Bart.
It's all good. Yeah, we got a question. So the question is from Michael. Thank you for the question, Michael. What about Postgres configuration changes?
Yeah, okay. That's managed by the operator.
Okay.
So there are some options that we don't allow users to change because they will break, the assumptions made by the operator, but they shouldn't matter. But pretty much all the options can be configured. We also support changes of some options that are, for example, they're required to be done in a certain order when you have replicas. So for example, you need to change them before in a standby or in a primary. It depends. Some of them, they have these requirements. So we also manage that. For example, the memory or the number of connections that you enable, they need to be done in a specific order. But essentially, the operator detects if the change requires a restart or not. And if it does, it starts a rolling update, which can be done in two ways, either via switchover or via restart of the primary. So it's all configurable. Yeah, but thanks for the question.
Good. Thank you, Michael. Perfect.
Excuse me. So we have implemented these two types of import. One is called microservice and the other one is monolith. This is some terminology that might be is subject to change, and this is a terminology that we have invented. So if you've got better names, please go ahead. So on the left, we've got the source database, which is a Postgres 9.6. So I use 9.6 because it's not supported, but it's pretty much any Postgres version. In this case, it's a monolith Postgres installation, which is very typical. In an instance, you put several databases. I often call it DBA approach. Okay, the idea here is to map each database into a one Cloud Native Postgres cluster with one database inside. So that's the microservice approach, because the microservice database is owned by the microservice developers and the microservice team. Okay, so in this approach, each database is mapped to a different PostgreSQL cluster with one single database. Okay, and if you want to know more, I think if you read the Why Run Postgres in Kubernetes article, you get the reason for this. Okay, this is the monolith import instead. Okay, we pretty much remap the same scenario inside CloudNativePG. So you've got on the left a Postgres 9.6 database with several databases, and you import all of them in the same instance. I'm not a big fan of this approach because of several reasons. Again, please read Why Run Postgres in Kubernetes, but it's primarily resource management and also upgrade paths and also accountability and responsibility from developers. Okay, I think this is more agile. Each product is independent. And this is the YAML file that, for example, imports the DB1 from 9.6 into Postgres 14.3 cluster in Kubernetes. As you can see, there's a bootstrap section here with initdb. Initdb is the default bootstrap method, and it means create a new cluster from scratch. We use the import section specifying that we want to import using the microservice approach. And we want to import only the DB1 database from the external cluster called PG96, which is defined below. So below, we specify how to connect to that database using the Postgres user, and to connect to the Postgres database as a jump database. And then we specify the secret that contains the password to access the Postgres database. This is a first implementation. We would like to make it possible to dump with less powerful user, but I think this already is fine. Anyway, now it's time for Leonardo. I can stop sharing the screen.
Thank you, Gabriele. So let me start sharing.
So this is a live demo from Leonardo, so.
Demo goes.
Let's do it. Let's pray. Let's turn to the demo. It's all good. Demos are what makes things exciting. Where we have that spark where things are happening sometimes for the first time. I don't imagine the very first time, but we'll be patient, and I'm sure it'll go well.
Are you able to see my screen?
Yes.
Just making the font a bit bigger.
Good. Thank you. That's always nice. Good practice.
Yeah. So, okay, let's start. First of all, I'm connecting now to a Kubernetes cluster created with kind. Kind stands for Kubernetes in Docker. And as you can see, it's an empty cluster. It's being created 10 minutes ago. Yeah. By the way, kind is really good. And if you want to play with a Kubernetes cluster or to want to test something, kind is great. And so, okay, now I install CloudNativePG. And to do that, we are just using the documentation. This is the home page of CloudNativePG. And this is the latest version. And then you can see we have an installation and upgrade section. And you can install it just applying the manifest. There we go. We wait for the pod, for the operator pod to be ready. There we go, fine, everything is fine. So now we have CloudNativePG, and this is an example. This is really similar to what Gabriele was showing before. As you can see, there is just, in this specification, a number of instances, 3, and the size of the storage. There is no image name, so the operator will just use the latest one. And what's important here is the number of instances, 3, and what happens. So as you can see, the operator is just creating the pods, downloading the images and everything. But the point is 3. Usually, 3 instances, like here, from a Kubernetes administrator point of view, that means I will have 3 pods at the end. And this is exactly what the operator will be doing. So this is what I was referring to as when we designed CloudNativePG, we were thinking about the Kubernetes administrator and not thinking about as DBAs. If we was thinking about as DBAs, that would mean we would have something like 2 replicas, because you have a primary server, this is implicit. Instead, here we have 3 instances. So I applied this simple definition, why the operator is working for me. I'd like to show you. Oh, I think this is better. So this is not simple at all, and this is how the operator implements convention over configuration. And as you can see, the operator, meaning the webhook, has completed the definition for us and added every information which is needed to create a Postgres cluster for me. So here you see the initDB method that Gabriele was talking about before. That means just create a new cluster, and you have something for monitoring. You have the configuration of synchronous replication, and you have a lot of Postgres parameters which are needed. Okay. Oh. So now we have the pods, and you have 1 primary and 2 replicas, 3 instances. But you also have services. I think this is better. So you have the read-write service, which is pointing to the primary, in this case 1. Then you have read-only, these are the replicas. Then you have any instance you can read, so everything. And any, that means any instance besides being ready or not. This is used mainly internally on the operator. But we also have secrets. And we have it, a basic out secret for the super user. This is the Postgres user. We have a secret for an unprivileged user, which is the one that applications should use against this database. Then we have several TLS secrets that are needed because the deployed Postgres cluster is using mutual TLS authentication for replication. So thinking about replication, let's see if it works. Fine. And this is the second code. This is a replica. So in the architecture of Postgres, you can't insert data here. Hey, replication is working. Let's test the third one. So everyone that ever deployed a Postgres cluster like this manually can appreciate the complexity that is behind this work. But the main point to be taken here is that just with a simple definition, you can have a Postgres environment ready for your application to use. So this is really important. We have a Ctl plugin that is really nice to inspect the status of a cluster. You can install with Vue. I should have it here. Ah, yeah. So this has more information about Postgres. And you can look here, the replication status, what's happening under the hood and everything. So I think thinking about the question by Michael, if I remember correctly, about the configuration change, I think this is going to be fun. This is a declarative operator. So to apply a configuration change, I'm just changing the specification, let the operator orchestrate that for me. So let's try this.
So for example, one option that is fixed and can be changed while Leonardo is changing the options is the log settings. For example, we require CSV log because we on the fly convert that into JSON and push it to standard output as you know any other container pod in
you can't change this. Okay, so this is too much for my laptop. Okay, so applying this configuration change is going to need a restart of the Postgres instances. So the operator will just start from replicas. As you can see, this is the third replica being stopped and restart. That replica is ready. The second one is being stopped and now is ready again. So as you can see here, this is magic happening. The second one is being promoted as a new primary. And then when the first one is demoted, it will be restarted. So now you have your configuration applied and your primary changed to the second one. This is a way to implement configuration changes. It's not the only way, as Gabriele was talking about. You can also have the operator restart the primary. But yeah, this is an example of what a rolling update is from a database point of view.
Yeah, the way we have developed that, just to reply again to Michael with additional information, is that we have two strategies. One is called unsupervised and one is supervised. By default, it's unsupervised, meaning that the operator, when it performs the rolling update, also will immediately proceed with updating the primary. Okay, and when it does that, it chooses one of the two available methods for updating. The default is the switchover. So it means that it switches the primary to the second one, to another node, or the restart. Okay, so restart means that it doesn't perform the switchover, simply shuts down the pod, changes the image if needed, for example, of the container, if you want to update the underneath image and restarts it. Okay. Exactly. But of course, for Postgres configuration, you don't need to change the image. But anyway, again, this is convention over configuration.
And there is no best one. It depends on the workload you are hosting. So yeah.
Correct.
I'm just changing this parameter here. This is not going to require a restart. And as you can see, nothing happens. So this is about configuration changes. Let's do something more fun. Okay, so as you can see, we have 3 instances and 3 PVCs. I didn't specify anything on the specification, so I just got new PVC using the default storage class, which is standard in kind. And so my primary, check. Yeah, it's still the second one. My primary is the second one, and let's see what happens if I just delete the primary. I'm going to do this. I think it's fun. I'm deleting the PVC too, so just deleting data. So what happens now? The first one has been promoted as a primary, as you can see. This is an automatic failover. And then the operator starting in the, I'd say, the normal activity, meaning reconciliating the specification with the status. The status is telling the operator that there is just 2 instances, and the user specified 3, because we specified 3. So the operator is going to create a new replica, and here it is. This is an example of a failover, and is actually a way that can be used to recover from a data corruption. And yeah. Checking these.
In this, can I ask another question? In this particular case, you know, like we've had Alexander Kukushkin from Zalando talking about Patroni. How does this way of managing failover in Postgres compare to something like Patroni?
Yeah, it's just different. Patroni is a really great tool, in my opinion, and Patroni has a different focus because it's going to manage different type of infrastructures. Here we have support. We are vertical for Kubernetes, and basically what's happening is that our pods are running just one process, which we call instance manager, and this is just the operator executable, and that is running as a child the postmaster and managing all. So everything is needed for a PID1, basically, to be a good citizen on Unix.
Got it.
Yeah, the postmaster is the Postgres server. Is the name of the process.
All right.
Yeah. Cool. So it's just different. And
yeah.
Oh, okay. So that was a failover. Let's play with something different. I want to do this. So this is really similar. I just scaled up my cluster and required 2 more replicas, and the operator is doing that for me. Obviously, as I can do this, I can also scale down. In that case, replicas are deleted. And yes, thinking about automatic failover. I think this is interesting. The operator is going, obviously, to choose the most advanced replica. You can configure streaming replication if you want here too. Yeah, I think that's enough for a quick overview. And I hope, yeah, I'm just trying to share with you the taste that you have while working with CloudNativePG. I think it's nice. Yeah.
I think it is too. And the demo gods were very respectful. So good job.
Yeah, we are trying to be good citizen in the Kubernetes community, and we are trying to focus on what a Kubernetes user is expecting from us.
Yeah, there's also, I think, on the observability stuff, maybe another time we'll focus on that, but we have an native Prometheus exporter, and you can customize queries using config maps or secrets, you know, provide these metrics.
That's good. Because that's the thing is that, you know, this kind of came up a little bit in KubeCon. You know, after every KubeCon, everyone wants to see like, oh, what's the trend? What's coming next? And this topic of you know, we frequently find observability mentioned in things like open telemetry, if we're talking about SREs and these kind of principles. But this kind of a concept getting into the data space, I think you said it really well. I think we'll need more time to focus more on that. But is this something that you see as coming strong in 2022?
Yeah, definitely. Yeah. I think we are also looking into also integration, also for tracing. So, but there's some known unknowns there, you know, even, you know, improving Postgres interaction with, you know, Kubernetes tracing tools. That's something, you know, what I was referring to before. Now that we're trying to bring Postgres in Kubernetes and hopefully widen the adoption of Postgres, we can provide more feedback back to the Postgres, you know, developers, and then bring Kubernetes to Postgres, which is also the other step, you know.
Got it. These are all really good points. And I like how throughout all of this, you're really emphasizing the point of empathy, that for some people that aren't accustomed to these environments and the concept of running Postgres in Kubernetes might be something a little bit uncomfortable for some people. As you mentioned as well, Gabriele, the things that we saw on LinkedIn recently are a reminder of the work that we're doing right now and the progress that we're making. So yesterday, I talked about this with Alkin yesterday in his live stream about, you know, ClickHouse and that we were seeing these comments. It's not surprising. What I will say, though, is that having been in the community now for a year and a half and getting folks such as yourselves from, you know, from EDB that have lots of experience in Postgres and understand that running data in Kubernetes, Postgres in Kubernetes can work, is not going to, you know, destroy your company in the process, and actually provides lots of benefits. I do feel like we're in a much better position now in terms of our knowledge and experience. So it's good to see that.
Totally, yeah, totally. So this is the last slide. I mean, and then I'll share the slides with everyone, and so you'll find the links there. But, you know, join us. There's this Slack channel. You know, try the software, and anything that you see there can always be improved. So, you know, anyway, so there's also the bi-weekly developer meetings. They are open to anyone. So, you know, as I said, we're trying to follow the example that the CNCF is setting, you know, so.
And I would say so far doing a great job. Easy people to talk to, very friendly, always interested in talking about these ideas. Plenty of experience in the Postgres world. Gabriele, earlier when you said 20 years experience, sometimes people, that's a big source of pride. And other times it's like, oh God, I really have been doing this for a long time. The older we get, the more that happens, and it's totally okay. But it was so cool to see, you know, this project coming about in the last couple of months, really seeing it get a lot of momentum and interest in the talk that you gave, Gabriele, in Valencia, as well as the whole EDB team that was there. And we're going to be connecting with them actually at the end of this month in London. We'll be with Vinny Grack, and looking forward to that, to be hearing, you know, about his perspective. So yeah, that being said, I'm looking forward to the next conversations with data observability. I think that's going to be a very hot topic. I imagine we'll be getting a panel set up around that. And as usual, very easy to interact with these folks on Slack. So if you have any questions or doubts, feel free to do so. Gabriele, can I get you to stop sharing your screen really quickly so I can share mine? Yep, good. As is tradition, folks, in our 134th live stream, it's amazing to be able to say that out loud. We have our amazing artist, Angel, who's in the background. We're doing all this cool stuff. And he'll probably tweet it later, but he's got his CloudNativePG sticker on his iPad as well too. So he's down for the cause. It's a good sticker. It's nice. And anyway, so we get a nice visual summary of the concepts that were covered. It was great to see a demo that had no problems. That was good. And I don't want to say it's uncommon, but particularly with how quickly you got things together, that was pretty impressive, Leo. So well done there. Thank you both very much for your time today. We'll be sharing this drawing in social media so people can take a closer look at it. And looking forward to the next conversations. All right.
Same here. Thank you, Bart.
Always a pleasure.
Well
Take care.
done, Leo. Thank you.